Hello, everyone. Okay, so let's start. Welcome, everyone. So today's topic is right-angled triangles. Has everyone seen the assignment? Have you managed to download the assignment? Can people hear me? Yes, okay. I hope that's the answer to the first question, right? So you've managed to download the assignment. Is that a yes? Okay, good. Okay. Oh, oh, sorry. I didn't mean to do that. That was an accident. Okay, so let me share my screen and we'll start. So while I'm launching the whiteboard, can you say, have you studied sine, cosine, and tangent in school? Yes or no? I'll repeat my question. Have you studied sine, cosine, and tangent? Oh, yes. Okay, so I've got lots of. Okay, excellent. Okay, that's good. So without any further ado, let's start. Right angle triangles, but mostly, like honestly, this is mostly trigonometry. So we won't be talking about sine, cosine, and tangent most of the time. Definition of sine, cosine, and tangent. So you probably know this. I'll just quickly remind you that if you have a right angle triangle, and then right angle triangle, then and you have an angle. So for example, you have an angle theta. The longer side, the side opposite to the 90-degree angle, is called the hypotenuse. The side opposite to the angle is called opposite. And this is the adjacent side. Adjacent. And then you have sine, cosine, and tangent. So sine theta is opposite zit over hypotenuse. Cosine theta is adjacent over hypotenuse. And tan theta is opposite divided by adjacent. And immediately we know that the opposite side is never bigger than the hypotenuse. That means sine theta is always less than 1. Okay. Similar for cosine, because the adjacent is always smaller than the hypotenuse, the cosine will always be less than 1. For tangent, well, opposite over adjacent, there's no limit. It could be anything. Well, if the upper limit of sine theta is 1, what do you think the lower limit of sine is? Sine theta is less than 1. What's the smaller limit? Cosine theta. 1. And tangent theta, we can say it's less than infinity, plus infinity, and greater than. Okay, so George says 0. Amelie says -1. Who's correct? What do you think? Well, yeah, if you remember the graph goes from +1 to -1. There, the biggest value is +1, the smallest is -1. Let's just do the graph. So y equals sine x. You see, sine x oscillates between 1 and -1. Okay, George, are you convinced that the lower limit is -1? Yeah. Okay. Cosine is the same, and tangent minus infinity. So this is just the limitations. Okay. Cool. Now let's. This is just the definitions. So a trig circle, a trigonometric circle, or sometimes called a unit circle. Are you familiar with a unit circle in trigonometry? 1 for yes, 0 for no. Are you familiar for the unit circle? Okay. All right, so mixed. Okay, let's look at a section of a unit circle. Is a circle of radius 1 drawn at the origin. Okay, so the radius is 1. So this point, this is x, this is y, this is 1, this is 1, this is -1, and this is -1. So if we draw a line like this, the length of that line is obviously going to be 1. Let's say that this point has coordinates x and y. Now, if I draw a triangle, a right angle triangle like this, okay, and just copy this here. This is 1. This side, well, if the coordinate of this point is 1, so this is 0 and this is y, of course. So this side is going to be y. And this side is going to be x. And if I take this angle, theta, then I can write down sine theta is opposite over hypotenuse. So it's y divided by 1, which is just y. And cosine theta is going to be adjacent, x divided by 1 is equal to x. Does that make sense? I'm especially interested in Param, Swasti, Wanya, and Maria. Those who said 0, can you tell me, does that make sense? Okay. That means that the coordinates of this point are linked to the sine and cosine. So x is cos theta, cos of that angle, and sine is and y is the sine of that angle. So if you draw a circle and you draw a line, the coordinates of the point of intersection will always be cosine and sine. Okay. Let me demonstrate that to you. I want to start over. Just show you how I use GeoGebra. Okay, so I'm in GeoGebra. This is a wonderful tool. And now the first thing I want to do is draw a circle. I can draw a circle just using this circle tool, or I can, no, I'll use the circle tool. Let's not worry too much. So I draw a circle, center this, and radius. Okay, so B should be 1, 0. Okay, that makes sense. Now I draw a ray. A ray is a half line from A to a point on the circle. And now for this point, I should label the value, the coordinates, and of course, I want like 4 decimal places. Okay, I still want 4 decimal places. How do I do that? Yes. Okay, 4 decimal places, and now I want the angle, so I need another half line, array. This is called array, and I want the angle, this one and this one. Okay. So this is the angle. The angle is 32.1 degrees. So I want to clarify. This is a circle of radius 1. Easy. A ray originating at 0 and going through the circle. It crosses the circle at some point. Okay, so let's me just move this point. Let's say I move this point so that I'll try to make 30, as close to 30 as possible. $30. What is the significance of that? That this angle, 30 degrees, and this is cosine of that angle, and this is sine of that angle. So cos 30 degrees is approximately 0.8687, and sine of 30 degrees is approximately 0.50. Well, actually, it's exactly 0.5. Okay, on a scale of 0 to 10, do you understand what we're doing? Please let me know. And this works for any angle. I change the angle, and I do. Oh, I don't need the whole circle. I'll just need the. Okay, so if I take this point, so cosine of 54.52 degrees is approximately 0.5804. Let's check. Right, so cosine of 54.52 it is 5804. And sine 54.52 degrees is approximately 0.8143. So this is a way of of linking sine cos for any angle. So just to reiterate, if I have a circle of radius 1 and I draw a line, then the coordinates of this point, if this angle is theta, the coordinates of this point is going to be cos theta and sine theta. And this immediately you can start answering questions like this. What is cos of 0 degrees? Something that you can't do with a triangle, but now you can do with a circle. What is cos 0? So you just find this point. The coordinate of this point is 1, 0. So the cosine 0, this is 0 degrees, yeah? 0 degrees. This is 30 degrees, 45 degrees, 60 degrees, 90 degrees, 90 degrees. So cosine 0 degrees is, somebody tell me? It is 1. And sine 0 degrees is, of course, the second coordinate, which is 0. Now, for 90 degrees, cos 90, you can immediately say, just looking at this at the circle, it is 0. And sine 90 is 1. Okay, we can go further. What about 180? 180 is this angle. Why not find cos 180 and sine 180? So what's cos 180? Minus 1. And sine 180 is going to be 0. Now cos 270 and sine 270. Cos 270 is 0, sine 270 is minus 1, of course. And then you can do cos 360 and sine 360. And you can check all of these values on a calculator. Cos 360 is 1 and sine 360 is 0. So now you have a tool that allows you to calculate sine and cosine for any angle whatsoever. And like if you want 180 degrees, that's this. 180 degrees, it's minus 1, 0. So cosine is minus 1, sine is 0. If you move it, okay, it's not doing what it's supposed to, but you can work it out. Like 135, that's 225, 240, 270, etc. So you can do this. Right. Can I share this so you can play around with it? I don't think I can share. No. Anyways, you can do it. You can do it by yourself. Okay. Now, okay, trig circle with any angle. So yes, you can find yes. Now, we call these quadrants. we call these quadrants. The 4 quarters of the circle are called quadrants. So if we draw a vertical line, so this is the y-axis, this is the x-axis, this is quadrant 1, this is quadrant 2, this is quadrant 3. Now let's not do Roman numerals, just quadrant 1, quadrant 1, quadrant 2, quadrant 3, and quadrant 4 quadrants. What's the significance of the quadrants? Well, in quadrant 1, we know, by the way, one very important thing, that sometimes the x-axis we will call the cosine axis, because cosine theta is x. Cosine theta is x. Therefore, we can say that this is the cosine axis. So this is 1. So if you have an angle like this, this is the cosine of that angle. So this angle is theta, this is cos theta. I won't overcomplicate things here, but okay. Cosine x, and this axis is sometimes called the sine axis, sine theta axis. So it goes from -1, remember, -1 to 1. And cosine goes from -1 to 1 as well. In quadrant 1, sine theta is positive, and cosine theta is positive. Now tan theta is sine over cosine. There is, so tan theta can be written as sine theta over cos theta. Let me prove this to you. So theta, this is opposite, this is adjacent, and this is the hypotenuse. Tan theta is opposite over adjacent. I can multiply this by hypotenuse over hypotenuse. I'm allowed to do that because hypotenuse over hypotenuse is 1, so I'm just multiplying by 1. And now I can switch these around. I guess opposite divided by hypotenuse times hypotenuse over opposite, adjacent. Sorry, adjacent. And now replacing the multiplication sign with the division sign, opposite hypotenuse divided by adjacent over hypotenuse, which makes it sine theta divided by cos theta. So tan theta is sine theta over cos theta. Sine theta over cos theta. So I hope you're convinced. And because sine is positive, cos is positive, tangent, which is sine over cos, is also positive. Okay, so in quadrant 2, we can see that sine is positive because the y-axis is sine, so sine theta is positive. Cos theta is negative because it's on the x, it's the negative side. And tan theta is negative because it's positive divided by negative. In quadrant 3, sine theta is negative, cos theta is negative, and tan theta is positive because negative make positive. In quadrant 4, this is sine theta is negative, cos theta is positive, and tan theta is negative. This can be visualized like this. If you take the quadrants, sine theta, positive, negative, because sine is positive for angles between 0 degrees and 180 degrees. In the first 2 quadrants, for any angle in quadrants 1 and 2, sine is positive. For any angles in quadrant 3 and 4, sine is negative. Do you understand what that means? Do you understand what I mean? On a scale of 0 to 10, please. Okay. Oh, lovely. Now, for cos, this looks like this. Cos is positive here, negative here. Cos theta. And tan theta is positive, positive, negative, negative. So in quadrant, these three are sometimes combined into a cast diagram. I'm not sure I really like it, but I'll just show it to you. Cast. So A is all, S is sine, this is tan, and cos. All positive, sine positive, only sine is positive because cosine and tan are negative in this quadrant. T means it's tan is positive, everything else is negative, and here cos is positive and everything else is negative. So cast diagram. If you like mnemonics, or if that's even a mnemonic, I'm not sure. Okay. The x-axis can be treated as the cos axis. So I have shown that. The y-axis can be treated as the sine axis. Can we have a tangent axis? Well, as a matter of fact, we can. We have. So if we draw a circle, and okay, so we have a circle and the axes. And remember that when we do why does it do that? No, I don't want to do that. Okay. Okay. This line, this point is x, and this is y. Okay. Now, if I draw, and this angle is theta, and remember that when you draw the side x is cos theta, and y is sine theta. Now, if I draw another line that goes like this, then where this line, this ray, meets this vertical line, the vertical line has equation x equals 1, of course, where this line meets. Obviously, the x coordinate is 1. So because this triangle is 1. But let's see what the y coordinate is. So if this is 1 and this is y, and this angle is theta, then tan theta is equal to y over 1. That means y is tan theta. Well, y, let's call it y dash, just because we already have y. This is y dash. This is tan theta. So this is the tan axis. This is the tan theta axis. Where this ray meets this line is the tan of that angle. Let's see if we can do this on this diagram. Okay, so we need another point. Let's say here. And we need a straight line. Okay. And we need another point. E. So let's say if I move this angle, you can see that the x coordinate is always 1, but the y coordinate changes. And we can work out here this is angle theta, 57 degrees. So sine 57 is 0.8393. Cos 57 is 0.5436. And tan 57, what's tan 57? Somebody tell me? 1.54. 1.5439. Yes. Okay. Amazing. I think it's so fascinating. So you take this triangle. You take this triangle and you work out that this angle is theta and this point is 1 comma tan theta, which is, I don't know. When I first learned about it, I was like, whoa, that's really nice. Okay, so do play around with it if you can build this. It's not very hard, so you just move this point, and then you can find the tangent of any angle. For example, tangent 45 degrees is 1. Tangent of 30 degrees is 0.6, roughly, ish, 0.57, etc. So, and of course, tangent of 90 degrees doesn't exist because it doesn't cross. The parallel lines don't cross. Okay. Lovely. So that's trig circle. Trigonometric transformations. So the two main trig identities that you need to know is tan theta. So trig identities. So the two easiest trig identities is the following. Tangent theta is equal to sine theta over cos theta. The other one is, we've proved that one. The other one is sine squared theta plus cos squared theta equals to 1. Let's prove this one. So prove the main trig identity. Is that sine squared theta plus cos squared theta is always equal to 1. This is called the main trig identity. Okay, so let's use a triangle for that. And let's call this A, B, and C. And this angle is theta. So sine theta is opposite over adjacent. Cos theta is adjacent over hypotenuse. Sorry, I said opposite over hypotenuse. I meant hypotenuse, of course. Okay. Now, Pythagoras theorem. Pythagoras theorem, which I hope you have proved in school. Pythagoras theorem is a squared plus b squared equals c squared. Divide all of them by c squared. Now, hypotenuse cannot be 0, so we're definitely not dividing by 0, so we are allowed to do that. It's going to be a squared over c squared plus b squared over c squared equals 1. So it's a over c squared plus b over c squared equals 1. But a over c, we already know that's cosine theta squared plus sine theta squared, which can be written simply as cos squared theta plus sine squared theta equals to 1. Okay? And another one that I want to use today, but I don't think I can prove it today. So I'm asking you to do something that you shouldn't do, is believe me, believe my word. That sine 2 theta, not that you shouldn't believe me, it's just like you shouldn't believe anything if a person is not ready to prove this to you. Or justify their words. Sine 2 theta is 2 sine theta cos theta. Well, let's not without proof, no proof today, but let's verify for some angle. Let's say theta is 30 degrees. So sine of 2 times 30 degrees is equal to 2 multiplied by sine 30 multiplied by cos 30. Sine, that's 60 degrees. 60 degrees is equal to 2 multiplied by sine 30. Sine 30 is 1/2. And cosine 30 is square root of 3 over 2. Something you will study in the assignment if you haven't already. Oh, I've lost the chat. Where's my chat? Okay. Yeah, and then 2 cancels, and sine 60 is square root of 3 over 2, which is true. So at least for 30 degrees, this formula is true. This formula, you don't need it for the assignment, but we'll use it today. So this is just another sine. It's called the formula for the double angle. Sine of the double angle is 2 times sine theta times cos theta. Okay, so the task is express sine, tan, cot, sec, and cosec via cosine. So let's do that. So to find sine in terms of cosine, well, we can use sine squared theta plus 1 plus cos squared theta equals 1. That means sine squared theta equals 1 minus cos squared theta. This is usually where I stop because I have expressed sine in terms of cosine, except I express sine squared. Why I don't like expressing sine, because then I do sine theta is plus or minus. So there is an uncertainty here of the sine. So you have 2 different values of sine are possible for a given value of cosine. And that actually makes sense because if cosine is fixed, because this is the cosine axis, there are always two different possible values of sine. Sine can be this or that. Right? There are two values of sine for any given cos. Okay, so this is just that. So sine theta, or, but this is preferred. I'll get there. I won't get to cosec. So Cheyenne, thank you for asking. Tan theta. Tan theta. Well, we already know that tan is sine theta over cos theta, but our task is to express it via cosine. But we already know how to express sine, so it's this. So it's equal to plus or minus square root 1 minus cos squared theta divided by cos theta. This formula becomes actually more beautiful when you express tan squared. So we've done tan, but if you do tan squared theta, it becomes 1 minus cos squared theta over cos squared theta, and that actually becomes 1 over cos squared theta minus 1, which is quite a beautiful formula if you ask me. You can write it down as tan squared theta plus 1 is 1 over cos theta. So tan squared theta plus 1 equals 1 over cos squared theta. This is another identity. There are literally hundreds of identities in trig. Okay, cotangent. Cotangent theta is 1 over tangent theta. So it's literally the opposite of that. So it's cos theta over sine theta, which is cos theta divided by plus minus square root 1 minus cos squared theta. Okay, tick. We express cotangent. Sec theta is 1 over cos theta. Oh, that's done. That's the definition. By definition, sec is 1 over cos theta, so done. Cosec theta, by definition, it's 1 over sine theta, which makes it 1 over plus or minus square root 1 minus cos squared theta. Okay. So one really good thing is you can always express one trig equation or one trig function in terms of another. Okay, they're all interconnected. Right, I hope that makes sense. Does it? Does it make sense? Okay. Okay, so let's practice. Show that. I hope everyone understands the triple equal sign. Do ask me a question if you don't. Happy to go through that. It just means always equal to. Okay, so show that. So what we do is we take either the left-hand side and try to make it simplified and make it into the right-hand side, or vice versa. Take the right-hand side and make it into the left-hand side. I have a strong belief that it would be easier to modify the left-hand side to match the right-hand side rather than the other way around. So this is the left-hand side, and I'm going to try to modify it. So what can I do? Well, the first thing that pops into my mind, I can just I can multiply everything with everything. Okay. The second thing I could do is try to simplify each bracket first. I think it's actually going to be easier if I just open the brackets. So expand brackets. All right, it's not as scary as it looks. Left-hand side. So I'm just multiply 1 by 1. So 1, so minus 1 over cos theta plus tan theta. Then I take the second one and I multiply it by everything. 1, 2, 3. So it's going to be plus 1 over cos theta minus 1 over cos squared theta. I multiplied this by that, plus 1 over cos theta multiplied by tan theta. Okay, plus tan theta times 1 is tan theta, minus tan theta times 1 over cos theta, then plus tan squared theta, because tan theta times tan theta is tan squared theta. All right, is there anything I can cancel? Oh yeah, as a matter of fact, this one cancels out with this one. Makes life easier. 1 over cos and 1 over cos cancels. Okay, so let's see what I'm left with. Equals 1 plus tan theta minus 1 over cos squared theta plus tan theta plus tan squared theta. Okay. Well, tan theta and tan theta, that's 2 tan theta. What about this one? Well, let's do 1 minus 1. So it's going to be 2 tan theta. That's kind of what I need. So I'll just keep an eye on that. Plus 1 minus 1 over cos squared theta plus tan squared theta. Let's combine these into one fraction. Or not. Could I have made a mistake somewhere? No, I don't think so. Okay. Also, what can I do here? Well, I can. There are lots of things I could do. Let's yeah, let's do these two together. Let's two fractions. So I multiply this by cos squared theta. So it's going to be 2 tan theta plus cos squared theta over cos squared theta minus 1 over cos squared theta and plus tan squared theta. Look, tan squared theta can be written as sine squared theta over cos squared theta. So as a matter of fact, these are all like terms. 2 tan theta plus cos squared theta minus 1 plus sine squared theta over cos squared theta, which is 2 tan theta plus cos squared theta plus sine squared theta. We already know that's 1. That's 1 minus 1 over cos squared theta. And the whole thing is 0. So 2 tan theta. Yes. Well, yes, I I didn't want to use that formula. Of course we could, because we already know that formula here. Yeah, we've proved that formula. Tan squared theta plus 1 is 1 over cos squared theta. Yes, but I wanted to base my solution on just the two original identities, tan and this one. So yeah, this is how you do a trig identity. So whenever you see this, so in your assignment, so where's that? Like for example, this one. This is problem 10. So problem 10. So 1 plus cot theta. Well, cot theta, that's cos theta over sine theta. Okay, just stick that in, right? And then modify. Same thing here. Tan is sine over cos, etc. Here, oh, this is a bit more sophisticated. It's a double star question. What you need here is you need sine squared theta plus cos squared theta to the power 3. You need this to expand this. Expand. When you're doing this question. Expand this and then something might be born from there. Okay, this one. This has a different notation. Sorry, I was a bit lazy. I took this directly from an old book. So this is tan 3 alpha divided by tan squared 3 alpha minus 1 multiplied by 1 minus cotan squared 3 alpha divided by cot 3 alpha, and that's equal to 1. Well, it doesn't matter if it's 3 alpha or just alpha, so it's just an equally valid angle. So what can we do here? Well, what's tan divided by cot? Oh, okay. Well, no, not really, not really a thing. Okay, so what do we do? Well, let's write down. So tan theta, that's sine 3 alpha divided by cos 3 alpha. So start simplifying. Tan, this is sine squared 3 alpha divided by cos squared 3 alpha minus 1 multiplied by 1 minus cos squared 3 alpha divided by sine squared 3 alpha divided by cos squared cos 3 alpha divided by sine 3 alpha. Okay. So simplifying this bit, you multiply this by sine squared 3 alpha. So this is going to be sine 3 alpha divided by cos 3 alpha. And then multiplied. And here you have sine squared 3 alpha minus cos squared 3 alpha all over cos squared 3 alpha multiplied by sine squared 3 alpha minus cos squared 3 alpha divided by sine squared 3 alpha and over cos 3 alpha over sine 3 alpha. Okay. You know what? I'm just going to make life slightly easier. So sine this divided by that. I'm going to replace the fraction by the division sign. It's this divided by this, right? So it's sine 3 alpha over cos 3 alpha divided by this monster, sine squared 3 alpha minus cos squared 3 alpha over cos squared 3 alpha. And then, okay, times sine squared 3 alpha minus cos squared 3 alpha over sine squared 3 alpha divided by cos 3 alpha over sine 3 alpha. Now I replace the division sign with the multiplication sign by flipping the fraction. Cos 3 alpha times cos squared 3 alpha divided by sine squared 3 alpha minus cos squared 3 alpha times sine squared 3 alpha cos squared 3 alpha over sine squared 3 alpha times sine 3 alpha over cos 3 alpha. Okay. It might seem very difficult, but actually we've finished. We've done everything because sine squared 3 alpha minus cos 3 cancels. And now we're left with sine 3 alpha times sine 3 alpha. That's sine squared 3 alpha. That cancels with this. Cos squared 3 alpha and cancels with this. And we're left with 1. Ta-da. That's it. I finished the whole thing. It looked horrendous, but then suddenly it just became super easy. Quick question. Do you think you can, if I gave you this exactly the same question right now, would you be able to do it on a scale of 0 to 10, please? 10, yes, and 1 for no. I have no idea what you've done. If I gave you the exact same question. So it's also okay. It's let me just explain what I did because it all comes down to working with fractions. So this is not a trig question. This is a fraction question. Can you manipulate fractions? Because literally tan theta, tan 3 alpha is sine over cos. Let's call it A over B. And cot 3 alpha, that's B over A. It's cosine over sine. And that's all I did. So I did A over B squared minus 1 times 1 minus B over A squared over B over A. If you replace, so A is sine 3 alpha and B is cos 3 alpha, then literally becomes this. So substitution. And then all you need to do is just play around with this fraction. So A over B, so it's A over B over A squared minus B squared over B squared times A squared minus B squared over A squared, and then this B over A. And so then A squared minus B squared cancels, and you're left with A over BA squared divided by B over AB squared. B and B cancels. A and A cancels, so it's 1 over BA divided by 1 over AB. AB cancels, so it's just 1. That's all I did. Just instead of A and B, I used cosine and sine. Do you think you understand it better now? So people who had 6, 7s, and 8s. Mhm. So yeah, I just literally I was working with fractions, and I know it looked horrible, but actually there's nothing scary about it. Just yeah. Okay, problem 5, and here we use something that you won't be using in the assignment, but this equation that sine 2 alpha is equal to 2 cos 2 sine alpha cos alpha. Something that you can use. Okay, lovely. So I'm going to modify the left-hand side here. Left-hand side is 1 minus 2 sine squared alpha divided by 1 plus, now straight away I can do 2 sine alpha cos alpha equals. Oh, it's actually so easy. I multiply no. Oh yes, I can see it. I replace 1. I know using 1 equals sine squared alpha plus cos squared alpha. I do sine squared alpha plus cos squared alpha minus 2 sine squared alpha. So I just replaced 1 with sine squared alpha plus cos squared alpha divided by sine squared alpha plus cos squared alpha plus 2 sine alpha cos alpha. Now here this becomes a sine minus sine, so it's cos squared alpha minus sine squared alpha, like terms, right? Over sine squared alpha plus 2 sine squared alpha plus 2 sine alpha cos alpha plus cos squared alpha. What can I do next? Can somebody help me? What can I do with the top expression? Factorize. Yes, rise. What does it become? Yeah? Sine alpha minus, cos alpha minus sine alpha, cos alpha plus sine alpha. This is a minus b, a squared minus b squared is a minus b, a plus b. It's a difference of two squares formula. And what will I have on the bottom? Sine squared alpha plus 2 sine alpha cos alpha plus cos squared alpha. What's that? Thank you, Ben. Yes, it is. It is sine alpha plus cos alpha squared because it's a completed square. So we are using a plus b squared equals a squared plus 2ab plus cos plus b squared. And now this cancels and we're left with cos alpha minus sine alpha. And here we have sine alpha plus cos alpha, but I'll replace it with cos alpha plus sine alpha. Now I divide top and bottom by cos alpha. Divide top and bottom by cos alpha. And I get cos alpha over cos alpha minus sine alpha over cos alpha over cos alpha over cos alpha plus sine alpha over cos alpha. So cos alpha over cos alpha, that's 1 minus tan alpha divided by 1 plus tan alpha. Full stop. Thank you. Yeah, we got the answer. 1 minus tan alpha, 1 plus tan alpha. Yeah, sorry for the weird notation, TG. But yeah, whenever you see TG, that also means tangent, tangents, as it is called. So that is equal to the right-hand side. Right-hand side. Okay. Problem 6. Nothing new. I won't be showing anything really new if you think about it. So here I'm just going to expand. I'm going to square it. So it's going to be tan alpha, because I'm just using a plus b squared equals a squared plus 2ab plus b squared. So tan alpha plus 2 square root of tan alpha square root of cot alpha plus cot alpha. Yeah, because tan square root of tan squared is just tan over sine squared alpha plus 2 sine alpha cos alpha plus cos squared alpha. Okay, so this is the left-hand side. Now, tan alpha times cot alpha. That's an interesting one. Tan alpha times cot alpha. Tan alpha times cot alpha. But tan alpha is sine alpha over cos alpha. And cot alpha is cos alpha over sine alpha. So pam, 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 that is 1. Yes, thank you. So it's going to be tan alpha plus 2 plus cot alpha over sine squared alpha plus cos squared alpha. That's 1. 1 plus 2 sine alpha cos alpha. That doesn't really help, does it? Well, okay, let's see what comes next. Tan alpha plus cot alpha plus 2. Okay, so we will write it as sine alpha over cos alpha plus 2 plus cos alpha over sine alpha. 1 plus 2 sine alpha cos alpha. We find the common denominator. For the top, the common denominator is going to be 2 sine alpha cos alpha. Oh, okay, now I understand. 2 sine alpha cos, oh, there's no 2, sorry, we don't need 2. Sine alpha cos alpha. So we multiply this by sine alpha cos alpha, multiply this by sine alpha, multiply this by cos alpha. And we get sine squared alpha plus 2 sine alpha cos alpha plus cos squared alpha. And here on the bottom we have 1 plus 2 sine alpha cos alpha. Now here I have a double fraction. I have a over b divided by c. This can be written as a over bc. You can verify that. but I'm going to use that. So basically this sine cos, it goes down. So it becomes, and here, sine squared plus cos squared, there's going to be 1 plus 2 sine alpha cos alpha over sine alpha cos alpha, open bracket 1 plus 2 sine alpha cos alpha. And this cancels. So it's 1 divided by sine alpha cos alpha. Now multiply both sides by 2, multiplied by 2. So I get 2 over 2 sine alpha cos alpha, which is 2 divided by sine 2 alpha, which is equal to the right-hand side. That's exactly what we needed. That's what we needed to prove. Okay, I've got 2 more questions to go, and they are geometry. So this is based on the last few questions where you need to use geometry to find like 18 or 17 or 15. 15. Okay. The sum of two unequal sides in an isosceles triangle is L. The angle at the apex is alpha. Find the side of the triangle. So this is, I think, the hard part in this is a good drawing. So we have an isosceles triangle. Check. The sum of two unequal sides. Ooh, not sides, sorry. Unequal heights. Otherwise it doesn't make sense. Sorry. L. The angle at the apex is alpha. Find the side of the triangle. Okay. What does it even mean? Well, we need to draw it, of course. Unequal heights. So first we need to draw the height. So the height is a line from a vertex that is perpendicular to the opposite side. So this is a height. Let's call it h1. Unequal heights. I mean, that means that we can't use these ones, right? Because these two are equal. So it has to use this one and another one. This one. This is h2. The angle at the apex is alpha. Well, so the whole angle is alpha, which makes this angle alpha over 2. And the side of the triangle, this side is, let's call it A. So let A is the side of the triangle. That means cosine of alpha over 2, cosine of this angle is h1 divided by A, right? Because A is the hypotenuse. If you consider this triangle, A is the hypotenuse, and this is the adjacent side. Okay. Now, this side, this angle is 90 degrees. This angle is alpha. That means that this angle is 90 minus alpha. Well, actually. And that means this side is also A, that cos alpha over 2, sorry, cos 90 minus alpha, cosine of this angle, is H2 divided by A. Okay. But interestingly, you will study this in the assignment, but cos 90 minus alpha is what? Does anyone know? Sine alpha. Yes. Sine alpha. And actually, you can use sine alpha is H2 over A, which is also true. Sine alpha. Okay, so what do we have? We have that H1 is A multiplied by cos alpha over 2, and H2 is A multiplied by sine alpha. But together, the sum of H1 and H1 is L. So H1 plus H2 is A cos alpha over 2 plus A sine alpha. But that's equal to L equals A, open bracket, cos alpha over 2 plus sine alpha. That means the side of the triangle is L divided by cos alpha over 2 plus sine alpha, and that's the answer. The side of the triangle is this. Okay. Problem 8. The height of an isosceles trapezium is h. Okay, so we have an isosceles trapezium. Is h. The angle between the diagonals, so we need the diagonals. Diagonals is alpha. So which one? This one or this one? Well, it says opposite to the side. So this is the side. So opposite to the side is this one. So this is alpha. Find the midline of the trapezium. Midline. What on earth the midline is? Well, if you have a trapezium, the midline is the line connecting the middle of the two sides. So the midline. And interestingly, if this is A and this is B, then the midline is A plus B over 2. Do you remember that the area of a trapezium is A plus B over 2 multiplied by height. So it's actually just the midline. Midline times height. It's an interesting observation. And actually, thinking about it, I just realized there's another way of doing this problem. Okay. Now, let's label these sides. Let's call this side A. That means this side is also A. This side is B, and this is also B. Okay, so we have 4 triangles. We have triangle, let's call it A1, A2, A3, and A4. The area of a triangle AB, so area is 1/2 AB sine theta. This is a formula for the area of a triangle. So let's look at triangle A1. So A1 is going to be 1/2 AB multiplied by sine alpha. A2 is also 1/2 AB sine alpha. Might get into trouble, but okay. A3 is 1/2 A times A times this angle is 180, so sine 180 minus alpha. And A4 is 1/2 B times B sine 180 minus alpha. But, and you will learn this, that sine 180 minus alpha is, does anyone know? Can be simplified as sine alpha. Yes, just sine alpha. Therefore, this is 1/2 A squared sine alpha. And this is 1/2 B squared sine alpha. So the total area, is 1/2 AB plus 1/2 AB plus 1/2 A squared plus 1/2 B squared multiplied by sine alpha. Well, actually, you don't really need the 1/2. So let's take the 1/2 out. Multiplied by 1/2 sine alpha. Okay, so total area is A squared plus 2AB plus B squared multiplied by 1/2 sine alpha. Total area is 1/2 A plus B sine alpha squared. Okay, but on the other hand, the area of a trapezium is the midline 1/2 AB 1/2 A plus B times H. Okay, and then combining these two, 1/2 A plus B squared sine alpha equals 1/2 A plus B H. A plus B cancels, 1/2 cancels, and we have H is equal to, oh, the midline, sorry, the midline. The midline is 1/2 AB. So 1/2 AB, A plus B. So the midline is equal to 1/2 AB, which is equal to H over 2 sine alpha. Full stop. And that's the answer. I didn't do it like this when I was preparing for this webinar. I did it differently. I said, okay, so we have the trapezium. So this angle is alpha. And so then I draw this angle, this line. So I call this H1 and I call this H2. Then what I do is I express this angle. So this angle is going to be 180 minus alpha. And that means that this angle is half of that angle, and that's 90 minus alpha over 2. And same here. If I do this angle, this is also 180. Well, this is also 90 minus alpha over 2. Okay. And the base of this side is A. So this is A over 2. And this is B over 2. Oh, I'm sorry. I've made a mess here because I've used the same letters for A and B. A and B mean different things. Ooh, I am in trouble. Okay, I'm sorry. Let's call it C, D, D, C. This is, oh, that was so silly of me. This is C and D, C, D, C, C, D, D, C squared, D squared, CD, 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 C, CD, D squared, CD, CD. Okay, so that's not the answer. Okay. Now, how is C and D linked? This is A and this is B. You kind of need to use the sine rule and the cosine rule here. Yeah, not the best method. Okay. So here, sorry, I was too quick here. Apologies. No, you can't do it like this. So let's do it. Let's go back to my original solution. So this is 90 minus alpha over 2. And this is A over 2, this is B over 2, of course, because that's half of that. And so I can write here that tangent, tan alpha over 2 for this triangle is B over 2 divided by H2. For this triangle, tan alpha over 2 is, tan if this is 90 over 2, then this simply is alpha over 2. And similarly, if this is 90 over 2, then this is alpha over 2 as well. And that means that tan alpha over 2 okay, is h1 divided by a over 2 and tan alpha over 2. And here is h2 divided by b over 2. And now I express h1 and h2. So h1 is a over 2 tan alpha over 2. So from here, h2 is b over 2 tan alpha over 2. And together, they make h1 plus h2 is a over 2 tan alpha over 2 plus b over 2 tan alpha over 2. And therefore, that is a plus b over 2 tan alpha over 2. And that's equal to h, of course. And that means the midline, a plus b over 2, which is the midline, is h divided by tan alpha over 2. That is the midline. Midline. And coming back to this, what can we say? How is link? Oh, of course. This is alpha over 2. And we can say that tan alpha over 2 is no, without splitting it, in half, it doesn't really work. Okay. Sorry for creating a mess. I can get out of this situation, but it's just it's going to take some time. I can use the sine rule. So here, use the cosine rule. Which you might not have studied. I'm not sure, but yeah. Okay, I hope this was useful for you. I hope some insights. I hope you enjoyed it. I'll see you all. Um, I'll see you all. Oh, when do I see you? And let's check this timetable. I hope you're doing this. So webinars. Y10 webinars is on the 18th. The 18th of November. Right. Enjoy. See you all in a few weeks.